All right, Peter Sharma is the Associate Sustainability Consultant at Stantec. He is a senior leader with more than 11 years of experience championing holistic sustainability and embodied carbon reduction. He fosters innovation and collaboration, delivering people-centric sustainable solutions tailored to clients and projects. As carbon lead for Stantec's education sector in Canada, Peter focuses on K-12 and higher education projects, alongside extensive experience in government, commercial, industrial, healthcare, and other sectors. His diverse portfolio equips him to understand, implement, and help clients tell their project sustainability story. Peter has served for over 5 years with the CAGBC, Canadian Green Building Council Alberta, including as Emerging Green Professional Chair, earning the 2018 Emerging Green Leader Award for his dedication to advocating, educating, and practicing green buildings and empowering youth and professionals. He is passionate about positively transforming the built environment, and Peter's dedicated to creating a healthier, sustainable world for future generations. And I get to work with Peter regularly through our work at NVIC, so it's really fantastic. We also have Colton, and you just told me how to say your last name. Bruff. He was like, Bruff, like rough, and then, yeah. So Colton Bruff, the Associate Senior Building Performance Engineer at Stantec. He is with the Carbon Impact Team in Calgary here, and he helps clients and design teams find innovative solutions to energy efficiency and carbon reduction goals through integrated design. He is passionate about high-performance design, and he specializes in energy optimization for new construction and existing building retrofits. He's got over 7 years of experience, and he's dedicated his career to solving complex energy performance challenges. And I don't know if there are any that aren't complex. He supports design teams in achieving sustainable high-performance goals across diverse building types in North America, and his deep understanding of standards such as LEED, ASHRAE, and zero carbon, and other regional policies enables him to identify unique opportunities and guide projects to where they need to go. So that's it for the introductions, and I'll let you guys get into it because I'm really excited to see your data.
Great, thanks everybody for joining. Just a second. Okay, who is excited to learn about schools? Embodied carbon, energy efficiency. So today we're going to be talking about how can we design Alberta schools for just and sustainable future. You learned a bit about myself, about Colton as well. I'll introduce you to Stantec a little bit. So at Stantec, we're a global leader in sustainable architecture, engineering, and environmental services. And in the buildings realm, we work across many sectors, but today our focus is on education sector, and we'll talk about how can we lead transformative change there. At Stantec, we're truly sustainability leaders. We don't just talk the talk, we walk the talk. And we're committed to net zero and science-based targets, and we're ranked amongst the top amongst our colleagues as well. So all this stuff that we do, Stantec has signed onto various commitments that tie into all those goals as well. So these are the targets set by architects for the architects and for the engineers by the engineers. So these industry pledges help us help guide our work in carbon, climate, and equity. So getting into the presentation, what are we going to learn about today? So we'll look at rethinking our design strategies potentially for schools in Alberta, and the impact on energy performance and embodied carbon in school design as well as looking at potentially modifying our approach with a focus on occupancy to improve design influence. We're also going to be looking at comparing different school rating systems and lessons learned from other jurisdictions as well that we can bring to our projects from day one. So as we begin to get into this, why does this matter? So the schools that we're designing and building today are, this is where our children are going to spend most of their time. And it is our responsibility to provide them optimal, healthy, and efficient learning and teaching environment. As we looked at all those building commitments that our industry is tied to, you see 2030 a lot. And 2030 is just 50 months away. Let that sink in. So 2030 is when we have declared that all buildings must be net zero ready, and by 2050 we're trying to achieve net zero, there's a lot of work that we need to do as an industry. And as we look at understanding the impact of climate change as well, that why those goals are there, it's not just warming that we're looking at. We're seeing a lot of wildfires. We're seeing heat domes. We saw the wildfire that decimated Jasper. On the opposite end of the spectrum, we're seeing higher frequency of deep freeze as well. We're used to deep freeze, but they're increasing. Hailstorms, the damage from hailstorms that we have seen billions of dollars of damages. So that's where sustainable buildings come in. And when you're looking at more durable buildings that last longer, are more resilient to climate. With that, I'll hand this off to Colton to talk a bit more about background. And looking forward to your slides here.
Thanks, Peter. All right, so before jumping into actual case studies, we want to provide you with some background that will help set the stage for the bulk of the presentation. So the inspiration behind this presentation was the announcement from the provincial government of a major investment into schools. So we're anticipating that around 200,000 new enrollments in K-12 schools will happen over the next 7 years. And with that, the government has promised an $8.6 billion investment in a school construction accelerator program that's anticipated to deliver or retrofit more than 100 new schools across the province. So these new schools or modernized facilities are there to ensure that students and teachers have the necessary space and resources for learning and to reduce overcrowding that we're seeing in our schools today. So our team thought, is this a chance to review how we design schools and reevaluate the sustainability and performance criteria that governs design to see if there's room to improve? So looking at our current approach to energy performance in schools and how we're designing schools currently, there's a bunch of different standards and codes that dictate the energy performance and sustainability requirements of our school designs. So looking at provincial regulations, we've got the NECB 2020, which sets minimum performance requirements for all buildings across Alberta. And we've also got school design policies such as the AI or Alberta Infrastructure TDR requirements that set specific requirements for schools. These outline specific sustainability criteria such as certifying with LEED version 4.1 and having mandatory specific LEED credits that need to be applied to all schools. Now we're currently looking to achieve certification with our schools for LEED version 4.1. However, we're anticipating that LEED version 5 is going to come along in spring of 2026, and our schools are going to pivot to certify and align with the criteria associated with that new policy and standard. So looking at some of the relative performance codes that we have and looking at the NECB and defining what it is. So it's a set of technical requirements used to establish a minimum design threshold for energy efficiency within the construction industry for new buildings and additions. Developed by Natural Resources Canada with the support from the Canadian Commission and looks at establishing requirements for building envelope electrical systems such as lighting and power systems, mechanical systems such as heating, ventilation, cooling, and domestic hot water, and provides a variety of different pathways to show compliance that allows for design teams to be flexible in their design approach, knowing that not all projects are designed the same and have different priorities. So why is it getting harder? So here's a timeline of where our codes were historically and where we're going. So looking at Alberta, we have adopted our first code in 2016, which was the NECB 2011. Since then, we've adopted a few more codes along the way, so updating to NECB 2017 and in 2019, and currently using NECB 2020, which was adopted early on in 2024. Now, we're heading towards 2030, like Peter alluded to, with the intent of having all new buildings being net zero energy ready or carbon ready by 2030. And then by 2050, having all new buildings and existing buildings being net zero energy or carbon to align with the federal commitments by the Canadian government. So other codes we see in Canada besides the NECB that dictate or influence some of our designs. So we also have ASHRAE 90.1, which is very similar to the NECB, where we're comparing relative performance standards to a baseline scenario. We've also got codes such as the BC Step Code and the Toronto Green Standard, which provide absolute targets or minimum performance thresholds, a little bit different than the relative performance requirements we see in ASHRAE 90.1 and NECB. So the important metrics we see in those different codes are relative energy savings or relative savings compared to a baseline scenario, but we also look at absolute targets such as EUI, energy use intensity, which is a measure of energy per unit floor area, GHGI, TEDI, and CD, which are also output metrics compared to floor area of a building. Now, what is a relative performance metric versus an absolute performance target? So absolute targets are a total measure of an output for a facility, often compared to a floor area. So you're looking at that absolute target in yellow, that minimum performance where the building has to be designed to at least be that performance requirement or below. Now, relative targets are a comparison between two designs, often comparing our design to a code-created energy model or requirement and measuring the relative savings compared to that minimum requirement. But Peter and I, developing this presentation, we're asking how can we better influence design? So are our current codes and standards helping us effectively influence design? Our current relative savings or absolute targets the best metrics to use when designing schools and other buildings? Are we designing buildings with the proper lens, or can we adjust to improve our actual design processes? And can we as sustainability consultants, energy performance professionals, climate analysts be involved earlier to influence and optimize energy performance throughout the design process? Now, I'm sure we've all seen a graph similar to this where we're looking at the ability of our professionals and designers to influence outcomes. So looking at the y-axis, the the ability to influence the design, and the project evolution on the x-axis, what we see is we can better influence designs earlier on during the design process, and as design progresses, we lose that ability to properly influence design, or our influence is more costly to the actual construction of a facility. So here's our typical starting process for an energy modeler being involved in the design as an energy modeling professional. We typically get involved during conceptual design or schematic design, where we develop a simple box model or energy model using floor plans or preliminary floor plans and design narratives. But how can we get involved earlier to better influence design as energy modeling professionals? So some questions that we asked are, can sustainability influence planning and functional programming? So how do we get involved earlier as design professionals? Can we impact planning, and what can we change in our processes to provide that value and get involved earlier to influence design? Now, one of the questions we asked ourselves when putting this presentation together is, are we designing buildings too large? Are our schools and facilities being designed appropriately sized for the occupancy intended for the space? Can we improve our process by reevaluating energy and greenhouse gas emissions through a different lens? Is there a metric that would help us improve the design process with increased focus on sustainability and equity beyond what we're already using? And will this help reduce energy consumption and improve school environments for teachers, staff, and the students who are going to be occupying the space? So looking at potential new performance metrics that we could use to potentially influence the design. So our prior focus and our prior energy metrics that we've been using have a focus on per unit floor area. So this is EUI, GHGI, TEDI, and CD. But we asked, can we also evaluate energy, GHGs, and embodied carbon, looking at a metric that evaluates against building expected occupancy? So looking at energy consumption per occupant rather than floor area, and then embodied carbon per person rather than based on your overall floor area. So jumping into the next section of the presentation, we'll look at evaluating designs based on occupancy instead of floor area. So we'll start off with a simple hypothetical scenario comparing two schools using our historic metrics such as EUI and relative savings compared to the NECB, but also evaluating that school based off of the new metric that we're proposing, energy use per occupant, and seeing how those compare historically and with the new metric. So looking at these two different schools, we've got school number one, it's about 1,000 meters square with 200 occupants. School number two, 2,000 meters squared, so double the size with the same amount of occupants set at 200. So evaluating those through the historical lens of EUI and relative savings, school number one's got an energy consumption of about 250,000 kilowatts. Now that translates to an EUI of 250 with relative savings of 18% over NECB. Now, school number 2 is considerably larger and has energy consumption of about 440,000 kilowatt hours. The EUI is set at 220 kilowatt hours per meter squared, and the relative savings is about 20% compared to NECB 2020. So based off of the metrics that we've used in the past, school number 2 looks a lot better than school number 1 with that more energy efficient EUI and higher relative savings compared to code. But if we change it up and evaluate that based off of energy use per occupant, we can see that school number 1 has a significantly lower energy use per occupant at 1,250 compared to school number 2, which is 2,200. So through this different lens, it completely changes our perspective on the design of these schools and how we're evaluating the energy performance. Now, why talk about energy use per occupant or design per occupant? Well, it encourages design teams to really rethink the programming and sizing of rooms so that we can ensure that we're adequately designing the spaces to be suitable for the occupancy that is intended to be used for. It improves designers' ability to reduce the overall energy consumption and reduces potential overuse of construction materials, saving costs and reducing embodied carbon where we're oversizing our spaces. And it increases equity across school designs, ensuring that all spaces are designed with the same intent. Now, we'll move on to actual case studies where we're comparing actual schools that have been constructed and certified across multiple regions. So we've got a group of schools specifically designed and certified within Alberta that we'll be analyzing. We've also got a set of schools in rural Manitoba that we can cross-analyze with. And then another set of schools within Michigan that were very high performance that we'll use as a lessons learned tool to compare against our schools in Western Canada. Now the focus is still on Alberta, so our sample of Alberta schools that we've newly constructed are outlined on the map on the right, so we can see we've got a group in the Edmonton area, a couple up near Whitecourt, and one up farther north near Peace River. So they all have similar performance targets. They all follow the Alberta Infrastructure technical design requirements, which from an energy performance perspective require 12 points, a minimum of 12 points to be achieved for the optimized energy performance LEED credit. But we want to evaluate how these schools compare from an EUI lens compared to that energy use per occupant lens. So here is a data plot associated with all the different schools from different areas. So the Alberta schools outlined in blue, the Manitoba schools outlined in orange, and the Michigan schools outlined in green. So we can see that Alberta schools have a fairly consistent plot in terms of its EUI on the y-axis. When we look at the Manitoba schools, a little bit more energy intensive compared to the Alberta schools, so a little bit higher up on that y-axis. And then those high performance Michigan schools quite low in comparison, and we'll dive into what these results really mean. So we still want to focus on the Alberta schools, so we'll dim out the other regions such as Manitoba and Michigan and really focus in on the Alberta schools that we've been involved in the design process for. So regardless of floor area associated with these schools, the EUI fits between two distinct boundaries. So we've got the lower boundary at about 200, an EUI of about 200, and that upper boundary of about 250. Now there's a 25% increase between that low boundary and the high boundary, creating, showing fairly consistent results across these different schools. But when we shift to the next slide to show energy use intensity versus occupancy instead of floor area, you'll see that some of these dots deviate a little bit. And so based off this deviation, we were able to tell that there's definitely a change in perspective and lens associated with evaluating schools through the lens of occupancy as opposed to floor area. Now changing up the y-axis to show energy use per occupant along the y-axis and floor area on the x-axis, we can see that there's immediate change in the results when comparing through a different lens. There's a larger deviation from that upper bound to the lower bound when comparing energy use per occupant compared to the traditional floor area. So our EUI range at 200 to 250 showed a 25% difference in energy performance compared to all the schools. Now that we're looking through occupancy, there's a 77% difference between our Alberta schools when viewing the building's energy consumption compared to occupancy. And when comparing to Manitoba schools, which have a higher average EUI than Alberta schools, now they show a little bit lower energy use per occupant than our highest Alberta school that we see on the data plot. But what does this data actually mean? Are buildings designed in that red area above that upper boundary built too large for the intended occupancy of the space? Are buildings designed with lower energy use per occupant built too small for the number of students and teachers in the space? And is this yellow area a region where we can confidently say that buildings are designed appropriately for the number of occupants? Is the minimum performance similar to what we see in the BC step code appropriate, or does the limiting building size too much create risk of designing spaces too small? Would a range with upper and lower bounds be more appropriate to design buildings within a boundary? We still don't know. But by adapting this lens and benchmarking the available data through newly constructed schools and existing buildings, we believe that designers can better position themselves to serve clients and ensure that we are designing spaces that are better sized, providing a more equitable learning environment based on a more holistic view of energy use. This metric wouldn't necessarily be recommended to replace EUI or relative performance, but could be used as an additional tool in our energy modeling process to evaluate energy performance of schools. Now, switching over to analyze the data points associated with the Michigan schools, the EUIs are very different than what we were seeing in Western Canada, so their EUI range has significantly decreased down to 49 to 92 compared to Alberta, which is around 200 to 250. So how can we modify this new metric associated with energy use per occupant to work with changing performance requirements? Could it be used like step code with increasing performance so that when we're looking to achieve higher tiers of performance associated with building design, we also adjust that range to suit? So some considerations when comparing these different groups of schools. So our Alberta and Manitoba schools focused on traditional systems such as gas or electric boilers. Our Michigan schools, which are much more higher performance, incorporated high performance electric systems such as air source heat pumps or geo-exchange heat pump systems with a bigger focus on long-term savings. So these schools use the tool such as a life cycle cost analysis to evaluate lifelong or building long costs rather than upfront costs to determine which mechanical system was most appropriate. So they ended up going with those high performance alternatives rather than our traditional systems that we often see in Alberta. Because they electrified their building, they also implemented a larger scale rooftop PV system to offset some of their electricity or increased electricity consumption, further reducing the energy consumption, increasing the energy performance of their schools. Now, some other general considerations associated with school designs that may cause variations and influence different values that we see in the performance of our buildings. There's differences in heating and cooling seasons even across Alberta, so we operate between climate zones 6 and 7. Depending on how far north or how far south you are, you might see variations in the performance of your schools that could dictate the energy performance of your building. Facility programming requirements could also have an influence. So schools where we have shop classes compared to K-6 schools which don't have shop classes might have different energy consumption associated with some of those facility programming requirements. There's consideration associated with expansion in the future. So if your school is anticipating a larger volume of students and we initially designed the school to have an expansion, that could influence energy consumption up front. And then school schedules and usage. So will the school be used during the summer? Will the school be shut down during the summer? Will it be shut down during the winter? Will the community be using it sometime in the afternoon or in the summer when it's historically shut down? This also is going to have an impact on your overall energy consumption. And then differing performance targets. So if we have different performance targets dictating the energy performance and design of our schools, then we can see variations associated with our energy consumption. So I'll pass it off to Peter to talk about some of the more holistic sustainability requirements associated with school design.
Thank you, Colton. Lots of great data and some considerations that we can implement in our projects here. Now, Colton has walked us through is operational carbon. So operational carbon is all the gas and electricity bills that make us angry, and we want to reduce those as much as possible, right? So that's operational carbon. And when we get into, I'm going towards embodied carbon portion of the equation now. Embodied carbon is basically the carbon associated with with where your raw materials are being sourced from, how far does it have to travel to manufacturing facility, and from manufacturing facility, how far does it have to go to your project site, installation procedures, so everything involved around energy that goes into manufacturing and transportation, installation of that product, that is embodied carbon. So the materials that we're surrounded with, drywall, concrete, steel, everything that we're surrounded with that has embodied carbon in it already, that's not the carbon that we can retrofit out. You have already spent that carbon. So we're going to be talking about embodied carbon here. Now, as we get into embodied carbon, how do you measure it? So the measure that you would see in the next few slides coming up would be carbon dioxide equivalence. So why do we use this metric? It's because there's other greenhouse gases as well that we need to compare with and need to have an apples to apples comparison. So it's a standardized unit of measurement where other gases are also basically we're given an equal amount of proportions to have apples to apples comparison. Now, why do we want to think about embodied carbon? As Colton had walked us through, the energy codes are evolving, and we can see our buildings are getting more and more efficient. The more efficient our buildings become, the more important that conversation around embodied carbon becomes as well, because that could represent 40 to 70% of your total carbon in your building. So it's really important, and it's a big part of the decarbonization equation as well. So decarbonization term you would continue hearing for over the last few years. It's basically that operational carbon versus plus embodied carbon. That's decarbonization. Now, a few other things that I will talk about shortly here would be getting into some health and well-being examples as well, climate resiliency and durability, and to balance all of this, how do we balance this with holistic sustainability? So getting into a few more graphs here for the data nerds here. So looking at carbon, here we're looking at embodied carbon intensity by floor area versus median income. So getting into social equity side of things here too. Starting with Manitoba schools in orange. So here we can see Manitoba schools are on lower end of the spectrum for median household income, and where they land in terms of your embodied carbon output. So there's a unique story to tell about these schools. So these schools are located in northern Manitoba. And think about it, to get to these communities, you have to access them through winter roads. If you need to get there in summer, you can only fly in there. So think about all the logistics and procurement challenges, labor challenges, and everything involved around building these schools. And we were able to keep our embodied carbon relatively low, as we'll look at the next few slides here too. For these, there was also financial incentive in place, because if you reduce the amount of waste that's generated, we have to haul lower amount of waste. And at the same time, the transportation costs associated with the materials, we incorporated a lightweight superstructure in these buildings that helped us reduce embodied carbon too, combined with a few other best practices that we incorporated. And here you'll see in green Michigan schools. So Michigan schools are showing a bit of higher intensity compared to our Manitoba counterparts, and that's partly due to added investment in durability and climate resilience. So they're using schools as community hubs in case of emergency as well. So that additional investment adds towards embodied carbon. We're gonna draw some conclusions later on too that yes, embodied carbon is higher, but how does it relate to social equity and cost too? And for Alberta, we have one lonely data point at the moment here, where it lands. So there's room for benchmarking and an opportunity for us to evaluate that as well. But in Alberta, it's not required by Alberta Infrastructure Technical Design requirements for us to account for embodied carbon, right? So it's done on an optional project by project basis. And we ended up doing that on one project. So we have one data point here for comparison. So summing this together here, overall, designing for equity means understanding context. We can see lower income regions in Manitoba can achieve low carbon outcomes as well. And in urban centers, we have an opportunity. If we can do that in Manitoba, in these northern communities, we can absolutely do this in Alberta, rural or urban environments as well. So the next metric I'm going to compare this against is, right now we're looking at median income here. I'm going to switch the x-axis now to capital cost. So just going to swap between these two a few times to show you comparison. So when we shift from median income to capital cost, this becomes interesting. We can see that Manitoba schools are on the higher end of cost here. And big reason being the challenges that I mentioned about logistics, procurement of goods, and accessing that site. And Michigan schools, as I mentioned, had higher investment for climate resiliency and long-term savings in mind here. And Alberta was on the lowest end in terms of investment here, as we can see, but was still able to achieve some good embodied carbon reduction there. So one thing that we learned from this between these two graphs is capital cost doesn't necessarily always correlate with carbon intensity. Now we're going to switch to another different metric here, looking at per occupant embodied carbon measure. And I'm going to swap between these two a few times too to show a bit of comparison. So this is embodied carbon intensity by floor area versus this is the occupant. So what we're seeing here is when we switch between these two, as Colton had represented in EY graphs as well, we see a bit more of a spread in terms of the higher and lower limits that we're seeing here. Similar comparisons, it just talks to potentially another lens we can look at projects through when considering occupants versus that capital cost. One thing that I would add to this equation is I'm going to switch back and forth one more time. So we're seeing the number 8 dot in blue for Alberta is going down. We can see that going down in terms of embodied carbon intensity per occupant. So that's an interesting thing that we're looking at. And when we're looking at these, some of the Michigan schools on the higher end still, one thing that I would add is that typically embodied carbon studies are done over a 60-year period in mind. But when you consider climate resiliency, if you can alter that to 100-year or 120 or 150-year, if you start comparing that in terms of comparing what climate resiliency measures could, how they could impact design. So these Michigan schools, as we're looking at these ones here, they incorporate climate resiliency, as I had mentioned, and we really focused on durability piece. Why is it important? We know that there are schools that are in Alberta that have a lifespan of 20 years or lower. I know, shocking. What does it mean if our project embodied carbon is on the lower end here? What if we have to replace it sooner than the Michigan schools, for example? That equation could suddenly shift when we start comparing with the bigger time slots here. So it's interesting to see how they compare. We're going to switch to another different metric now. So this was all embodied carbon. We're going to switch back to energy use intensity again, and comparing that with median household income. So Manitoba schools on the left, again, challenges that I mentioned that it had from median household income standpoint, it's on the lower end. Now, why are these schools on a higher end of EUY? So this is another conversation in itself, but to make it brief, there's no one solution that fits every single project. We have to consider what operations staff is able to utilize in terms of systems. If we provide complex systems, for example, in every region, that's when you end up seeing those complex systems being bypassed, and suddenly, boom, your energy savings that you projected are gone. So that's something that you have to work with the operations staff on. And we understood that these Winnipeg schools, 1 through 4 that we're looking at, they required that simplicity so that they could be maintained by the operations staff. Now, this Manitoba school on the right with 0 as representation is located in urban Winnipeg, but it's on the higher end because it's a renovation project. And we still did a great job in terms of reducing the energy use, but there's challenges around renovation projects too. Going towards Michigan schools, they show lower energy use in high income areas, thanks to early goal setting target and coordinating those targets to reduce energy usage here. And as we move to Alberta, we see the Alberta schools are located mostly in high median income areas with a relatively higher EUI. So the story that it's telling is that overall, it speaks to a bit of an opportunity that we may have in Alberta schools to consider long-term in mind a bit as well. And we're going to look at a bit more of this story later, but one thing I want to compare here now, similar to embodied carbon that we were looking at per floor area versus occupants, in a similar way, when we compare this by occupants, the energy intensity on the y-axis, again, we're seeing that that's spread again. So through this, we can draw some conclusions as well, but as Colton had mentioned, we don't have a concrete conclusion that this is the way that we should compare or replace EUI. What we're saying is we can potentially use this as another lens to design some of these spaces. The next metric I'm going to bring up is going to be EUI versus capital cost. So the 4 Manitoba schools that we're seeing on the right, 1, 2, 3, and 4, they show high EUI despite significant investment. Due to simplicity, as we had discussed, and 1 Manitoba school you see closer to Alberta schools that are going to come up in a bit, given the challenges of renovation project. And Michigan schools show higher investment and better outcomes with long-term savings in mind. So this is, in a way, a call to rethink our funding priorities potentially too, when we're looking at Alberta schools with a relatively higher EUI and low investment despite high median income. So when we start comparing all these, again, we can really rethink our funding priorities here and think with long-term in mind. When we compare this EUI versus capital cost from an occupancy standpoint too, we see between the two, the spread, similar to how we were looking at it before. So the equation stays similar in a way, but that spread could mean that we can potentially look at different ranges. Now, to sum this all together in a way, this slide is bringing together income versus investment. So what is the capital cost per occupant that we're seeing in these schools versus the median household income? So the gap that we're seeing in Alberta is pretty stark. High income, low investment, and it's a spicy topic. The teacher strike is going on right now as well, asking for better funding per student, right? So there's an opportunity there, and this graph is aligning with their ask as well for higher funding per student. So we can have world-class education, being the rich province that we are, and really invest in our children, in our future leaders. Now, one thing that I would say to keep in mind is that this equation would likely shift with this $8.6 billion investment that is being fed over the next 7 years. And also keeping inflation in mind too, that these are bound to go up, but how can we reduce that gap? How can we look at this differently? And how can we look at this with long-term in mind, with long-term savings in mind? But that better funding could support more equitable and sustainable and more durable and climate resilient schools. And one last graph for comparison. So this one is drawing a bit of a contrast and shows on the y-axis, you're looking at square feet per occupant, so you're looking at it by size, and the capital cost. So one thing that we can say is the larger schools can still be high performing. So the Michigan schools previously, as we were looking at from EY standpoint, we were looking at, is it designed to be too small? But it's not. The amount of space that we're providing per occupant is higher in those projects, and at the same time, they're more efficient compared to the schools we're looking at in Alberta and in Manitoba as well. So this could be used as a lens for equity. More space for students can mean better learning environments, and this is and tie this metric to capital cost and life cycle cost. By tying that, we can look at potentially higher initial investment that we may do could yield in lower operating costs and longer lifespan of these projects. Now we're going to go into a bit of comparison in terms of holistic sustainability. So from LEED standpoint, when we're comparing these urban versus remote and rural locations, remote locations usually have to prioritize energy efficiency, water use reduction, indoor environment quality, because urban locations usually have it a bit more balanced because they have better connectivity with location, transportation, site options, and the metric that we saw in a few slides prior, simplicity in systems that we see in remote and rural environments as well. When you're looking at urban, you have a bit more of an opportunity in terms of complex systems that you can tap into. Now, embodied carbon is interesting because if we can reduce embodied carbon in those remote schools, we can absolutely do that in urban environments. There's an opportunity there. One last thing that I would add quickly here is those remote schools that we were looking at in northern Manitoba were LEED Gold. Every single one of those. So if we can do that there, we can absolutely do that in Alberta, in urban or rural environments. Now we're going to shift to Michigan projects. What are the lessons learned that we can potentially incorporate here? So those Michigan projects pursued a rating system called CHIPS, CHPS, which is a specialized rating system for K-12 schools. Now it has been acquired by USGBC, so it's going to, a lot of the requirements are going to fall under the priority stream for LEED version 5. LEED version 5 is a whole conversation in itself. If you have questions about it, feel free to reach out. Yeah, that's the rating system we utilized. A few other highlights from those projects that we can bring in here: anti-idling measures that we incorporated, radon testing. Yes, we do radon mitigation here, but with radon testing, you're able to tell, do we need more mitigation? Share table storage and donation was another interesting thing that we incorporated. Basically, we provided an additional refrigerator for any leftover meals for the day. Those leftover meals would go into that refrigerator and go towards nonprofit organizations so that there's lower amount of food waste. We looked at, we incorporated operational IAQ plans as well, CPTD, CPTED principles. CPTD is crime prevention through environmental design. So those principles help us build schools a bit safer through design. Some examples include you can have natural surveillance through clear sight lines, or you can utilize your landscaping as to show where public and private spaces end as well. So a few examples there. We also incorporated school gardens. Another really interesting thing that we did on these projects was integrating with curriculum and incorporating educational displays and demonstration areas in these schools. So an example that I will give would be in some parts of the schools we used a plexiglass ceiling where you can see through the ceiling the mechanical, electrical, and plumbing systems. We color-coded those, and students are able to tell what those components do. So we did that throughout the school to help students understand how their building is more sustainable. We also incorporate biophilic and responsive design, inclusion of school staff in design charrettes, as well as the embodied carbon and climate resiliency focus that I have repeated a few times now. So one last example that I would like to share from indoor air quality standpoint would be this. So this is an idea that came out of our talented group in Texas. It's called Zen. So it's basically a pop-up prototype prototype sensory space designed by our team that could help frustrated students or staff feel better. There's a variety of different sensory-enabled architecture spaces that we had set up, and the outcomes that we got from these. student felt more relaxed, recharged, peaceful after utilizing these spaces. And the feedback that we got from students, they felt better after using these spaces. They were feeling ready to learn, and they had good energy. So these spaces, from health and well-being standpoint, could be incorporated in our projects as well. And given all this positive feedback that we got for Zen, it's always on a roadshow from one school to another, in conferences, universities, with just overall great demand given the health and well-being benefits that they are bringing to those spaces. So we went through a lot of information today. A few key takeaways for you folks. So today we covered energy, carbon, equity, well-being, and design influence. And new metrics we explored as well, like energy per occupant, that could potentially offer fresh perspective. And we can potentially rethink how we design our schools, not just for performance, but for justice and sustainability with long-term in mind. We understand that early involvement of sustainability, energy, and climate teams is critical in incorporating those lessons learned early on in the project so that we're actually integrating those instead of having those as addition items. These lessons that we learn from other jurisdictions can really help elevate our Alberta schools. And again, a call to rethink our funding priorities as well with long-term in mind. LCCA is a tool Colton had mentioned, life cycle cost analysis, as a decision-making tool that we utilize, that we can look at informing your long-term return on investment and diminishing returns as well. And overall, these lessons, I mean, we talked about schools, but they could really be extended beyond schools to MURBs, offices, any typology that we look at from a sustainability standpoint. So thank you, everybody, for your time. Thank you, NBEX. Thank you for BUILDEX and the support staff as well. We'll open it up for questions. Hey.
I was just wondering, like, how do we implement some of these new metrics? Because I find it super interesting, because we can look at all these efficiencies and really bring down that cost. We see a lot of projects not getting off the ground because it costs too much, and we can't find that level of efficiency. This is an incredible metric to bring forward. How do we implement that at, like, early design or pre-con, or, like, where do we get that started?
As early as possible. So we can look, as Colton had mentioned too, that this is a separate lens that we can use in addition to EUI, and then start comparing spaces based on what are the sizes of these spaces, and really working with before the programming is done. Even a lot of times too, that could give us an opportunity to help inform size of those spaces too.
And I would add that we have a lot of great data. There's a lot of existing schools and new construction builds available. We just need to benchmark that data to understand what that metric actually means. So we have a ton of different sources explaining EUI, but we can leverage that benchmarking to understand what that looks like per energy use per occupant or per occupant, to really try and implement that earlier on and adjust our lens and adjust our viewpoint from a sustainability and energy performance standpoint.
There's just a big opportunity in terms of, before, if we are brought on during schematic design, a lot of those decisions are already made for us, right? So that's why we want to be involved as early as possible. So great question. Yeah. Yeah.
I think with Alberta education, Alberta infrastructure doing this many school build-outs, are they aggregating all of this data and looking at that metric with you?
They may be or they may not be. Hopefully they are. Yeah, great question. Thanks, Audrey. Anybody else? Hey.
The final slide here, you mentioned that this is not for schools, but also looking at MURB, different types of buildings. That comparison hasn't been done. If you have any projection of it would be worse, better, how they compare with the school usage?
So this is our first kick at the can at really analyzing this, like from a perspective of schools. If we have the available information, once again, benchmarking can really help identify some of the trends we see with other building types to really formulate an idea of what that energy use per occupant could be from a minimum performance threshold, similar to what we see in BC with the step code, or like create a range associated with each performance step to really identify if a building is built per occupant in a specific range that's suitable for that building typology.
Yeah. Okay. Any more questions? Okay. Thanks, everybody.
Yeah, appreciate it. Thanks, everyone.